All right. So I'm going to talk about keyspace construction for the Open Toolkit. I know everybody's really excited about this. Nothing I say is true. This is me. I've been doing this for a long time. All right. So I'm going to talk about keyspace construction and what it means. Talk about some of the issues in the current code. Talk about the code that I'm experimenting with creating, and then where we're going to go. And I want to stop by saying this is not intended to be a critique of the current code in Open Toolkit in the sense that, this code is broken and, I'm really upset about it. The code that's there is there it goes back to at least 2010, because there's a statement in one of the source files which says 2010, and it may go back before that. So the code's 15 years old. I don't even know, Jarno, if you've touched it.
I wrote it.
You wrote it? Okay, well, sorry. It's fine. This is, of all the things that you have to do with data processing, this is probably one of the most challenging. And so I don't want this to be seen as, some sort of attack on Jarno. I also understand that of all the things in the code, this is probably the thing that Jarno wants to spend the least amount of time on. So, let's take some load off of Jarno. This is, I can explain why I really care about this a lot and why I'm happy to spend some time on it. So what I'm going to present to you is basically an experiment, a software development experiment to see what would happen. It is driven by our needs at ServiceNow, but it's not a critical need yet. All right, so this is an open source project in the data community organization on GitHub, data community keyspace builder. And so basically what I'm trying to do is re-implement the keyref module to implement support for ServiceNow's huge key-heavy maps. So ServiceNow, we have a single product, ServiceNow platform. We publish about 60 publications, totaling about 60,000 topics, and we maintain 3 versions in service at any time. So we have to publish the content for those 3 different versions all the time. So a single version of our product represents 60,000 topics. We don't normally publish those as a unit, except that sometimes we have to. And so that's an interesting challenge. About 2 years ago, we decided to rework all of our content so that it used keys for everything, right? So we now have on the order of 1 million keys for one release version of our content, right? So we have more keys, I suspect, than anybody else on the planet, maybe, right? So what I'm showing you is the solution to an edge case, but it's our edge case, right? Most people do not have this problem. They should, but they don't. They should, because everybody should be using keys for everything, right? All right. So in processing our documents with the current toolkit, what we discovered was that there was a memory issue that for our largest possible publication. So one of the publications we have to create is one that's all the content for a single release as a single publication. So all 60,000 topics under one map. When you try to process it with Open Toolkit with all the keys, it doesn't work. Open Toolkit gets the keyref resolution phase and never comes back. You saw those glaciers that Robert had? Yeah, it's basically that. Yeah, it's not really, it's not Jarno's fault that it doesn't work. It's something else. It fails for 2 reasons. One, it runs out of memory. The other is the processing will never complete in non-geologic time. So I want to try to reduce the memory footprint and improve the performance. So the question that I had was, is this even possible? Is it possible to write code that would do this, or is it an unsolvable problem, and I'll have to figure something else out? Now, one of the things that we've done within ServiceNow is we've written Python code that processes these same maps, does the same keyspace resolution in Python, and that works fine. So I knew it was programmatically possible, right? If I can do it in Python, I can do it in Java. So the question was then, all right, what does it mean to do it in a way that works with Open Toolkit? There's another issue that's to some degree more serious, which there's actually some logic errors in the current code in which it will, under certain circumstances, give you the wrong answer for key resolution. So we'd like to fix that. And then I'd also like a more general Java keyspace construction code, because there's other contexts in which you might want to be able to do interesting things with your key spaces that's not just Open Toolkit. All right, so then this is an open source project. Okay. And what I was going for, my hope was that I could just make a drop-in replacement for the keyref reader object. So if you look at what the keyref phase of the toolkit does, the key class is the keyref reader, which is the thing that actually gathers all the keys up and resolves them so that then you can resolve those keys in a map. So I wanted to be able to just replace that class with a new one, and everything would be Jade. Didn't quite work, but close enough. All right. So in order to talk about what I did, we first have to understand how keyref resolution works. And there's 3 phases to processing keys. First, you gather all the key scopes. Then you pull the key defs up from child scopes into their parent scopes. And then having done that, you push all the keys down, and now you have a completely constructed key space with however many key scopes you have. And one thing that's important to talk about here too is in Ditto 1.2, we introduced keys, but we didn't have key scopes. So a given Ditto map was a key space of exactly 1 scope. And that made things pretty simple. Ditto 1.3, we introduced scopes. Scopes are really important because they allow you to do certain use cases that you couldn't otherwise do. There's a lot of reuse cases that scopes are essential for, but it complicates the data processing a lot. And that change from 1.2 to 1.3, the addition of scopes, you can see that reflected in the code, right? The code worked fine for Ditto 1.2, doesn't really work for Ditto 1.3. Most use cases it works fine, right? So I want to say that, right? If you're not doing complicated things with scopes and you don't have a million keys like we do, it works fine, right? It works fine. It's only when things get sort of on the edges like we have that it's bad. All right. So the input is your resolved map, right? You pull all the submaps together. Now you've got a single map with everything in it. All right. So you walk the map to construct the initial key scopes. You pull the key defs up. And as you do that as you pull those key defs up, you add the scope names to those key definitions. So your subscopes, those keys get added to the parent scopes with the key names. So now your scopes know about the scope qualified keys underneath them. And then having done that, you push everything down. So now all the key scopes have a copy of every key that was pulled up and all the keys that were defined in the parent scopes. At the end of that, every scope knows about every key, right, in some form, possibly in its fully qualified form, and any keys that were defined in the parent scopes have effectively overridden the same key name defined in lower scopes. And now you're ready to resolve your keys. All right, so let's see how this works. So I have a map. It has some key scopes. Yeah? So phase 1, I just find all my key scopes and look at the key definitions that are in there, and I realize this is too small to read, but you get the idea. In phase 2, we're going to pull up keys from below. And I've highlighted a case where I have 2 different scopes. So if you'll notice, I have a scope named scope 1 and another scope named scope 1. They both define the same key name, key 2. So when I pull them up, in my root scope, I get a single key, scope 01.key2, that has 2 different key definitions. And those key definitions are in an order, which is the priority order as defined by the data spec. Right? So the first key, the one in the first scope named scope 1, is going to have priority over the second key def. But let's say I filter out that first key scope, that first key definition. Now the second one will be effective. Right? So if you think about it in this way, I need to know all the key defs in case I want to filter some out. All right, so now I'm going to push down all those keys, and you can see my set of keys gets much larger, right? I have a very simple map, right? This is a trivially small map, but I get a table of 38 rows that reflects the fully populated key spaces. And here I've highlighted a case where the key 1, is defined in the root scope, and it's defined in scope, the first scope 01, and you'll notice here, I have two key definitions for that key 01. The one that came from the root scope, which has higher priority, and the one from the, scope 01. All right, so everybody got that? So the rest is just a simple matter of programming. But I say that in all seriousness, because the programming is not hard. Programming is not hard. All right. So a couple of key takeaways. Key scopes are identified by their key definers. That is, the elements in the map that define the key scopes. Key scope names are not identifying. In fact, when Chris Nitsche first developed the key scope proposal, he didn't even have scope names. Because you don't need scope names, really. I mean, you do, so you can refer to keys and scopes, but the scope names themselves are not the identifiers of the scopes, right? The other thing is that a given scope may have any number of scope names, which is interesting. So the push-down phase results in a lot of key definitions, right? We went from a map that had, what, 7 distinct key definitions, to nearly 40 key definitions in the fully populated key space. Right, now multiply that by 1 million, right? So you get the idea. Priority is important, yes. The other thing is that fully qualified keys are known to all key scopes, because after I pull everything up and I push everything down, everything gets into the root space, right? I pull everything up into the root key space, and then when I push that down, I'm pushing everything down into all the descendant key spaces. This is another important point. Partially qualified keys are not necessarily known in a given scope. We have that example in this map here, right? I can have a key that if I reference it, an unqualified key, or a not fully qualified key, if I reference it in one key scope, I can resolve it, and I reference that same key in a different key scope, even if it's the same scope name, I may not be able to resolve it because it may not be known by that partially qualified name in that key scope, right? And that's the issue that the current toolkit code has, is it doesn't handle that case correctly. And I believe that's already a submitted, I think that's a logged issue, right? But it would be challenging to correct the current code to fix that, right? So the way that it's currently implemented is just some problems. I'm not going to spend too much time on this, but the end result is that you end up with a large memory cost, and the processing becomes inefficient at very large scales, right? And again, let me stress, for normal size maps in normal people's environments, it works fine, right? I mean, obviously people are using the toolkit every day with stuff that's got keys in it, it works fine. It's just when you get up to the scales that we've got, it doesn't work. All right, so what did I build? And let me see, because I'm doing okay for time. All right, so I wanted to change the code so that key scopes are identifying by their scope defining elements, not by their scope names. And I wanted a single key scope to reflect all the scope names. One of the things that the current code does is for every name for a scope, it actually creates a separate object in memory with that set of keys. And that's both wasteful and unnecessary. I want the key definition to reflect all the key defining topic refs that define the key name for that key def in priority order. The current code, for every key definition element, there's exactly one key def object. And that results in more objects than you need, and it also loses knowledge of what the set of key definitions are for a given key name, therefore precluding your ability to dynamically determine the effective key definition, say, using filtering. And the other thing that's important is that key resolution requires that you know the map context, right? Once you have scopes, you cannot resolve a key definition, a key reference reliably unless you know the map context in which that key resolution is happening, right? If I have a topic that makes a key reference, and that topic is used in 2 different places in the map, and I try to resolve that key, I can get different answers for each of those resolution instances in those 2 different map contexts, right? So I have to know the map context in order to resolve a key reference. So my construction logic uses a simple iteration. Yarno's code uses these clever map reduce features in Java. I don't really understand any of that stuff. That's too clever for me. So I did it a much simpler way. It may or may not be the case that the map reduce has some inherent memory issues. I really don't know. I haven't had the chance to test that. But the actual code that's needed is so simple that the map reduce, I'm not sure, adds any value from a software engineering standpoint. But maybe I'm just a simple guy. The other big change I make is that I update my keyscope objects and my keydef objects in place. The current code does a lot of copying, and that's I don't think the best way to have done it. So the other thing I want to do is move indirect topic ref resolution out of the keyref reader for reasons that I'm not going to go into because we don't have time. All right. So I'm going to show you some code, and I know you can all read that. But my point of putting this code up is not to show you the code, but to show you how little of it there is. Because one of the things that I came to realize in doing the implementation work I did in Python is that at the end of the day, it's actually really simple to construct a keyspace once you've figured out how to do it. So this is just walking the keyscopes, and then this is actually constructing the keydefs. And it's just a simple recursive process that's just like any other XML processing you might do. But just to make the point, this is the entirety of the code that does the keyspace construction. Right? That's all there is. It's everything else is the hard part that I haven't replaced, which is the actual modifying of the maps and rewriting that out and working in the context of Open Toolkit's internal record keeping and so forth. That's more challenging, but the actual just construction of the keyspace is pretty simple. And so here's the actual implementation of the pulling up and the pushing down. So the pull up just pulls the keydefs up, push down, pushes the keys down, and then you're done. Now, to be fair, Yarno's code is 2 or 3 lines because he uses that map reduce stuff. So, but this is what I understand this. All right. So my performance results. Now, so we have this huge map, has 188,000 plus keys. Right? It's a full ServiceNow product content set as one publication. And it's simply, like I said, it just, Open Toolkit 3 and 4, it won't work at all because it's too big. In my code, the constructed keyspace takes 4 gigabytes of RAM. That's still a lot, but it's well within what I can do, for example, on my laptop here, which has 16 gigabytes of RAM. The construction runs in a few seconds, and that's consistent with the Python code that I wrote that does the same thing. All right, so that means I should be able to process, if I can take this code and integrate it with the larger keyref processing, I should be able to process our insanely huge map with Open Toolkit, no problem. All right, so what do I need to do? Need to implement the indirect topic ref resolution. There's some complexity there that I haven't had time to do. Now, the other thing too is I've been doing this on the weekends, so this is definitely free time. Right? In fact, my daughter was like, "Dad, why are you working on a Saturday?" I'm like, "This isn't working, this is play? Right? So she's like, I don't know. Because we've talked about this. You're not supposed to be working on a Saturday. It's like, it's all good, it's all good. Talk about it. Implement breadth first map processing. So the data spec says that when you process maps in order to construct your key spaces, you process them in a breadth first descent of the tree. Now, I put that in the spec. I have no idea how to implement that. To be quite honest, it's very, very embarrassing. And as I've thought about this problem in several contexts, I'm like, I'm not even sure how to do that. So anyway, that's still an open problem. The way that the current code is written, the classes for keyscope and keydef are defined as Java records. I didn't do that in my initial implementation. That was a mistake. I need to fix that. But that makes integrating them with the current code harder. And then I want to see if there's, can I do some profiling and see if there's a way to make it even faster than it is. I mean, the code I have running now is perfectly fast enough in that it completes in my lifetime, but it can always be faster. Anything? Yeah. And so I want to. So the next level up in the Java code is the keyref module, right? So the keyref module is the Java code that actually does the whole keyref phase, and that's got a whole lot more stuff into it. In trying to integrate my keyref reader into what's currently there, I realized, yeah, I really have to make a copy of it and modify it, and that's a lot more work. It's going to take a few more weekends. So, but I'm still working on that. I mean, it wouldn't be fair to just say, hey, your code's broken, but I'm never going to fix it. That would be sort of mean, right? So let's try to make this work, and then hopefully we can provide something back that does the right thing for everybody, including my insanely huge map. Right, so it's got to work in the world. Now, my work motivation for doing this is eventually I would like to be able to put this in production for our build processes so that, you know, we just speed everything up and everything just works. And contribute that back. All right, let's see if I can show you this working. So just to show you what I've got, no. How do I get back to, no? There we go, okay. Maybe? I don't know how it works. All right, well, I'm not gonna, I'm not going to worry about it. My demo just, the code runs, you see it runs quickly, and it really works. There you go. It's no more exciting than that. What I was trying to show you is that in order to open this insanely huge map, I can't actually use Oxygen. Oxygen can't usefully open it because it's too huge. So I had to use a different editor, but it's there. All right. Well, now let's see, what was the option here? Swap displays, yes. Well, now I don't know how to get back to that option. All right, well, that's it. All right. Thank you.